Hi everyone, this is Jason Edelman. In this video, I'm going to take a look at standing up a big switch, a big cloud fabric, and doing that with the Schprokits automation framework. So right now on the screen, what you can see is one of the four switches that I have that'll be part of these spine leaf fabric. So this will be two spines, two leaves. These are Acton white box switches. They're 5710 and 6700 model switches. So right now this is just looping through the Oni bootloader looking for an OS to load on the switch. And you can see here real quick actually that the properties that I'm consoled in are slightly changed from a traditional Cisco and whatnot, baud rate. So this is 115.200 that I'm using to be consoled in. So right now at this point they're plugged into a management switch, and they are receiving an IP address from a local DHCP server, and then right now they're looking for a for a location, right, to download an operating system, right, using Oni. And so right now, if we were to look at the big cloud fabric login here, what we can do, we minimize this to fit into the screen here. And if we log in, right now there's two controllers that are booted up from Big Switch. And if we log in, we should see no configuration. And we do see two controllers, an active and a standby, and then we have a virtual IP address. So it happens with Big Cloud Fabric using their controllers. As you boot them up, there's about half a dozen questions to answer in terms of giving it an IP address, giving it a cluster name, things like that. So it's pretty basic. Other than that, there's no configuration. So if we were to go to the fabric, we should see just two controller nodes, again, active and a standby, no spines, no leafs, no other switches. And then look at tenants, right? So again, there's no configuration here yet within the big cloud fabric. So the first thing that we're going to do is configure the big cloud fabric to be aware of the switches that are right now continuously booting, looking for an operating system. So what we're going to do is go into our Schprokits virtual machine here and create a workbook that does this for us. Okay, and what we're going to do is prepare this. I already started the first 10 lines here, but what this is saying is info is arbitrary name that gets displayed as you execute a Schprokits workbook. So right now I'm just calling this a hands-off deployment for Big Cloud Fabric, and then we're giving this activity a name, saying BCF now or Big Cloud Fabric now, and then this is relevant for the groups called Big Switch in our hosts inventory file. And if we were to look at that file real quick, we can open up that file and open up the host file, and we can see that this gets mapped, this group called Big Switch gets mapped to this group called Big Switch here. So if we were to go to a prompt, right, this big ping big fabric, we can see it getting resolved to 192.168.200.102. So we know now this is just essentially the virtual IP addresses being used for the controller cluster. Okay, and then I have a variable defined here called lab status, and we'll see what that means in a second. And then we're also importing variables from another YAML file, and this YAML file is called bcf_poc.yaml. And then if we take a look at this YAML file, we can go here real quick and look at the variables that are predefined. So we're essentially templatizing the configuration that we want to deploy on the Big Switch Big Cloud Fabric. So we can see here that we want to deploy 3 tenants, and a tenant here is essentially like a VRF. So we're going to have a tenant called production, one called test, and one called lab. And within each tenant, we're going to have 3 segments deployed. So we're going to have the web segment, app segment, and DB segment. And then for each segment, an associated layer 2 construct that we're calling a VLAN here that gets mapped mapped back to access ports. So anything that you want to connect into the network will get mapped inherently to this VLAN ID, right? So we're using VLAN ID terms, but essentially it's a layer 2 construct that we're giving it a VLAN ID. And this is true as well for the test segments and lab segments, right? So essentially what we have is 3 identical tenants, prod, test, and lab, each one with web, app, and DB segments with the VLAN range 100, 200, and 300 being used respectively. And on top of that, what we have here is layer 3 interfaces being used, and I have something else being done for the prods, for the prod interfaces. But essentially, if you were to treat this as a layer 3 switch for web, app, and DB segments, you would want a layer 3 interface per segment to allow communication between these 3 segments. So again, I just have 3 layer 3 interfaces, 1 per segment that we're going to use. And this is just defining the variables in a separate YAML file that we're going to import as we execute this workbook. Okay. So the first thing that needs to be done in a big cloud fabric is to let the controller know what switches should be allowed to connect into the controller network. Okay. And this is done today based on the MAC address of the switch. So what we're going to do is leverage an action within Schprokits called BCF _ provision switch. And we can actually see this if we look at the built-in documentation. Alright, misspelling there. This is actually SPK doc. So what we see is built-in documentation, and then what we can do is just narrow this down to look at the big switch actions here, and we can see that BSN BCF will get all of those. So if we were to do SPK doc minus C for connector, BSN BCF here, and just do a clean this up. So we can see that we essentially have a handful of actions that can be used against the big switch, big cloud fabric. So the first one that has to be done here is the provision switch. And if we want to see what can be, and we can see the short description here, config provision switch in big cloud fabric. And if we want details on this one action, what we can do is SPK doc and the name of the actual action. And this is provision switch. So this action takes in a handful of parameters, and this is the group for leaf nodes. Big Switch uses a concept for groups that if you want to do lags on ports and whatnot, they need to be a part of the same group. The MAC address of the switch. This is pretty important. That this is going to be the key on how the controller determines what switch to import. The name, which becomes the host name of the switch. The role, leaf or spine, and we can see the choices available to us. And the state. We have the ability to say this MAC address and this host, the switch, should be present on the fabric, or it should be absent, meaning it should not exist. And these actions are idempotent, meaning if the controller in the fabric is already in the desired states, no change will be made on the fabric. Okay? And the default here is present. So if we didn't specify the state, the default would be present. But I'll definitely state this explicitly, so I want to make sure that it's clear what's going on. So if we go back here to our workbook, we're going to do actions, and what we're going to do is info again is arbitrary. This gets displayed as we execute the workbook. We're going to provision our spine switch, or one of the spine switches. And here, this is where we actually call the action that we were looking up in the documentation. So we do BCF provision switch. And if we go back, this is where we see these parameters, right? So this is where we're going to name the switch, and we're going to say spine 1 top. I'm calling it top because right now this is in the top of my rack. Okay. I'm going to grab the MAC address that I have in a separate file real quick. I'm actually going to grab the other parameters, speed things up here. So what we're going to do is just take a look at this. And I just pulled the MAC address. You know, this is actually on the switcher itself, or console into the switch and grab the MAC. So we're sending the action BCF provision switch, the name, which is spine1-top, the MAC address here. As you can see, the role we're assigning this switch is spine, and the state is coming from the variable lab status. If we double click lab status, you know, we see here that was absent, so we want to change this to make sure this is present. Okay, and then I'm doing a variable for the state, because this will speed things up if we want to blow things out real quick in terms of deleting configuration or adding configuration. And what I'm going to do, again, just to speed things up here, is just copy these over from a file that I already had this pre-created in. And so what we have here is the 4 switches now in the fabric. So this is in a Schprokits workbook here. I'm going to save this file, clear this out, and then what I'm going to do is run this workbook now. And we can see here the workbook name is big switch underscore BCF.yml. Okay. So this runs, and that literally took, maybe 1.5 seconds here, and we see changes that happened. And this is provision switch 1, or I'm sorry, misspelling here. I was spinning, that should be spine. All right, and that error just came from this misspelling here. All right, so we're going to change that and resave the file. So we had 4 changes here. So what we can do actually real quick is go back into the fabric. We're going to refresh this. We now see those switches coming up. Leaf came up here, and I didn't go back to the console, but we're actually we would actually see the switch now downloading and installing the proper switch operating system that was given to the switch by the Big Cloud Fabric as the Mac was keyed into the fabric. Okay. So if we go back here, within, I believe in these switches here, every 20 seconds, or the ONI bootloader is looking for a new OS, right? So as we can see here, these switches look like they're pretty much all green here. And if you looked at the errors and the warnings, okay, so by now they're all good. So we have no errors. Back to the fabric, system okay in the top left. We now have 2 spines, 2 leaves. And if we were to go back and do this real quick, we now see the lab status variable is present. Let's just say you want to blow this out real quick and delete all the Macs from the fabric. Let's just say they were the wrong Macs that were imported and they're part of a different network. So we can clear this out just to keep this clean. We can actually rerun the playbook. It connects to the controller, and we see the changes happening. And if we go back to the web UI and refresh this, we now see there's no more switches part of the fabric. Okay, and we don't want that to be the case because we want to build this out. So we're going to say present. Rerun this again. And what I'm going to do now is run it one more time. So we know now the switches are part of the fabric. And we'll see what happens if we run this again. So we see here there was no changes made. So we see the green OK, where in the previous tasks they were actually changed. So in this execution of this run book, there was no changes made here. So change 04 OK. And this is because the action is idempotent, meaning again that if the fabric is already in the desired state, there's no change being made. All right, so now the fabric is essentially ready to get configured, and there's a few actions that we can use here. And the first one that we're going to use is to create the desired tenants. And to do this, what we're going to do is say just info create tenants, and this is BCF tenants, and we can always go back to the SPK docs if we want to see, see the details on this. And this would be SPK doc BCF tenant. So we can see this one's pretty simple. So the params here, we have to send this as the name, which is required. Anything in the asterisk is required. To give it a tenant name. In the states, the default is present. I'll use that anyway because we have the lab status variable declared. That we're going to essentially make sure that we have the 3 tenants created as part of this. And there's in no particular order. We can just say states equals lab status. Actually, what I'm going to do here, if you remember, we actually have the tenants. I'm just going to copy and paste this into this file just for demo purposes, and I'll delete it in a second. So what we're going to do is loop through that tenants list. So we're going to say for each of the tenants in the variable called tenants. Let me spell this right. Tenants. Can I spell today? Tenants. Okay. And that tenants references this variable called tenants, but it's actually in the bcf_poc.yaml file that's being imported up top. Okay. And the name of each tenant typo is _each. And as this loops through, this will be production, test, and lab. And this just saves time using these kinds of loops. That way we don't need 4 lines every time. And we could do a for each loop as well for the switches, but just for demo purposes, I'm changing things up here. Okay. And that way we have the state lab status and the name as well. Okay. So right now what we can do is, again, save this. Sublime, disregard that. And I always like clearing this out to keep this simple. What we're going to do now is rerun this workbook. And what we should see is 4 OKs for the switches, because there's no changes being made there. And this is repeatedly doing these tasks. Unable to process workbook, BCF tenants. Okay. So if we were to look here, what actually happens, and if we were to go back into the doc for big switch stuff, BSN, BCF. Okay, so that's a typo. So it's actually BCF tenant, not tenants. All right, so that was my mistake. We can resave that. Again, I always like clearing this out to have a nice clear screen as we run the workbooks. All right, so we saw 3 changes here. So these 3 times it looped through the tenants variable. Again, that was stored in the BCF POC YAML file and created 3 tenants. And again, just as checks and balances, we can always go back to the fabric, go to the tenants, and we now see 3 tenants here: lab, production, and test. Okay. And there's a blank configuration. It's literally created the equivalent of like 3 VRFs here. Okay. So now what we need to do is create some more configurations in the fabric. So we have 4 switches stood up. We have 3 tenants. The next thing we need to do is to create the logical segments for each tenant. And what we're going to do here is go back to the workbook, and in the effort of time, I am going to copy and paste from another file that I have pre-created. We're going to copy, put back in this file, and if we look here, I just copy and pasted this stuff. Right, so we're calling the BCF segment action. We're giving a tenant name production, tenant name test, tenant name lab. And then for each one of these, we're looping through again. So we have production segments, test segments, lab segments. we're using the name here, which if we go back here, again, these are the segments, and this is just a different built-in variable. So we're saying the segment name is underscore each underscore name, which actually maps to these to the actual name that we're assigning here. And this is just the key within, essentially like the first, the first indentation here, within YAML. And this is just YAML syntax. But essentially that gets mapped to the segment. And as we see here, these are the same. So web app DB, web app DB, web app DB for these segments here. Okay, and then within the segments, we are assigning it the VLAN ID as well. Okay, tenant name, segment name, and that is happening. Well, let's just double check something real quick. If I want to, I just want to look at the docs. And this is just checks and balances. RSPK doc, VCF underscore segment. So what we can see here is the overview of VCF segment. So here what we're doing is configuring a big Cloud Fabric segment for a given tenant. And then there's two little caveats here that, as part of this, we're configuring a VLAN ID. The way it currently works, you'd have to remove the segment and re-add the segment to change the VLAN ID. And within Big Cloud Fabric, there's the notion of port groups, interfaces, and switches for membership. So right now, what I'm supporting here in this action is just any, meaning when a new VLAN is created as part of a segment, that VLAN is getting added to a VLAN trunk that gets added to the host ports. So in this configuration, the server that connects into the fabric would need to be a virtual switch that configures trunking on both sides, right? Or on the virtual switch side. And what I'm doing inherently here is configuring these VLANs on all ports. And that's just because I created this action, right? It's something that I built personally, and if these were physical servers, then I would simply modify this action to support added parameters. And again, this was just in the effort of time, creating actions for Big Cloud Fabric, that this was a simpler way to get things up and running. All right, so what we're doing here, again, is creating the segments with these associated VLAN IDs. So real quick, we're going to save this file. Excuse me. Clear this. And we're going to run this again. And we see the new changes. We can go back to the fabric, come to the tenants, and if we can just pick a tenant here, production. We can scroll down and we can now see logical segments within the production tenant. We see app, DB, and web. And then if we were to go into app, we now see the VLAN for app. Okay? So this now created essentially 9 new VLANs for these segments. All right? And just for the heck of it, we can actually go into the CLI of the controller. Do I have that set up here? It doesn't look like it. So let's just go in here, 200.100. I do have it already set up. So let's just go into the controller. Username admin. Log in my password. So right now, there's also a CLI in the controller. We can do a show run on the controller, and we now see what's actually happening on the back end. So what we see, this is what I was talking about earlier, any interface is now part of VLAN 301 on host-facing ports, right? So we have 101, 301, and 201 for prod app, and again, you can see here the associated DB and web, so these are essentially the equivalent of .locq trunks facing the servers, okay? So let's just go back to our VM here. So right now, again, what we've done here is 3 major things. The first one is provisioning the switches. The second is creating tenants. And the third is creating the segments, okay? And the last one, what we're going to do is, I'm going to copy this in the effort of time here as well to speed things up. And these essentially could be different workbooks. You might have one workbook, for just provisioning switches, one workbook for creating Tenants, and this could be, based on how the actual fabric is rolled out, right? So ideally, one person might not be doing all this. You might have an administrator of one tenant, just giving them access to the workbooks to create segments within that tenant and so forth, right? So what I'm going to do here is I just copied in everything from line 37 down, which is everything here. And what I'm doing here, like the first one here, these three sections are for the production tenant, right? So here we're doing a new action, and I'm just indented. You can have your parameters and variables underneath the action or laterally going across. So here, just because there's a few different variables, we're saying, again, create logical router interface for the production web segment. And here with the associate saying this is for tenant name production, the segment name web, we're going to give you this the logical layer 3 interface of 10.100.1.1/24, and the state we want it to be present. We do the same thing for production app. We do the same thing for production DB here, okay? And then for the last two tenants, to simplify things, these are a lot simpler versus doing it in manually. Here we're just we just defined these interfaces in a YAML file, right? So it just simplifies what can be done. And then within these, we're doing a for each loop to loop through those three, where again, for production, there's no loop, and each one is done manually. And there's no right or wrong way to do this. It's just a matter of, as you architect more workbooks, you might like to use loops as time goes on versus doing it manually. But again, if you like seeing all the data right in front of you, there's nothing stopping you from doing it like this. So I'm going to save this file. Okay. And again, rerun this workbook. And as you can see, everything that's already pre-provisioned is always okay. And things being changed are what was newly added. So what we can do is, like we've been doing, is go back to the fabric, go to the tenants, go to production, and what we now see is logical segments that are added. So we now see app DB in web, and we're actually on the production tenant here. You can see that in the URL, production, and we now see 10.100.213.1.1.1. And if we were to change this, go back to tenants. If we were to go to test, then we see the proper 10.102.xx for that tenant. So what we can do is, once this workbook is created and finalized, which right now it pretty much is finalized for what I want to demo, is this is the equivalent of 3 VRFs, 3 VLANs per VRF, and now there's connectivity within these segments for each tenant. So if you want to do a proof of concept with Big Cloud Fabric, you can take this workbook, replicate it, and literally have a POC built in seconds. And when I say seconds, what I mean is, if we change this back to absent, clear this out, run the workbook, that's going to run and make all these changes, go back to the fabric. This is a bare bones fabric now, and those other switches will actually end up getting removed in a given period of seconds. But essentially what we have here is in tenants, like there's nothing more in tenants. So if this was your starting point, you now have a saved workbook. You can go to your DR site, disaster recovery site. You can go to another data center and literally run this workbook from the ground up. We'll now see, before I do that, I do have to remember to change this back to presence. We'll run this, and we'll see changed here now in everything, because everything is being changed. So we had 25 changes, essentially 25 actions, including, each change within a for each loop is its own change. And if we go back to the fabric and refresh this, we now see the network. And again, within seconds, we'll see the connectivity coming back up. But we already see within tenants, we see our 3 tenants. We go into prod. We see our IP addresses and VLANs are all there. I don't have any servers hooked up to actually test connectivity, but you can press the I believe button that AppDB and web can all communicate to one another within a given tenant, but they cannot between tenants. And if we go back to the fabric, we now see the leafs are up, and it's just a matter of ONI on the switches every 20 seconds rebooting to ensure they're going to find the controller again. Okay, so we see now that the system is literally back up and running within seconds. And these creating actions are custom. So, if we go back real quick here and look at the SPK doc for BSN, this is Big Switch Networks, Big Cloud Fabric. That was SPK doc -C. So this was 1, 2, 3, 4, 5 actions that we used 4. And what we can do real quick is there's also another action called get config. I'll demo real quick. And again, just because I'm just going to simplify this, what I'll do is I'm just going to copy and paste this real quick. What we're doing now is creating a second activity within the same workbook. So we're just going to change this. So we're going to say get data. We're going to give this as a different name. And we're just going to say get BCF, the same groups here. And create actions. And we're just going to get config data now. And this action is called BCF get config. Config equals switches. And if we look here, this was SPK doc, and this is BCF get config in real time. So what we can see here is config equals choices switches, tenants, logical interfaces, segments, or all. So we can actually retrieve all the data, or just to do a check, right? Again, if there's multiple fabrics deployed or just one, and you want to just do a quick check on which switches are deployed, we can do a params config equals switches, and that'll be a basic one here, and which is what I have here, and then basically that's going to get the data, and the data being returned, we can actually, let's just say that's my data. So the data being returned is in the form of JSON. So we're going to store that data in a new variable called my data. And since what we want to do is just dump this to the screen, we can just say dump vars name equals my data. And this is actually going to dump the data being returned from the previous action to the screen. And here what we want to do, I'm going to minimize or shrink this. That way it'll make more sense. I'm going to clear this. And rather than run the full workbook, what we can do is do -A for the activity name. And the activity name down here was get BCF. So we can just do get BCF. And then if you recall, we have 4 switches here, 2 spines, 2 leaves. So this should actually display the data unrecognizable in general. Okay. That was my fault. This is what we want. So -A. The name here is get BCF. So this just ran the activity on the bottom. And this could be cleaned up a little bit, or you can actually create reports off of this data. But you now can see the MAC address, the name of the platform, the type of the switch, PowerPC AS6700 Acton switch, the serial number of it. So you now can get the DPID from Big Switch, right? So you can do a quick dump of just doing get data, right? So if we wanted to see other data, we can actually use the the params and change config to tenants or something. But this was just a really quick demo of standing up Big Cloud Fabric, again, literally in seconds, once workbook is defined. And you could, right now I'm going to turn this down. I'm about to go to lunch. So what I'm going to do is blow this config away and say absence. And I'm going to run the full workbook. And what this means is I'm doing, if you remember on the bottom, the second activity is to dump vars for the switches. That should actually return no data right now. Okay. So this is deleting everything, and you can see here, config, nothing's returned, because by the time it hit the second activity, everything was already removed from the switch. Okay. And that is all I have for you today. Thank you very much.